English medium instruction has rapidly become the standard in global higher education. Universities worldwide are adopting EMI programs to internationalize their curricula and attract diverse student bodies. But pursuing a degree in a non-native language imposes a severe two-fold burden. Students must simultaneously translate the instructional language while trying to comprehend entirely new, highly complex professional terminology. This creates a cognitive bottleneck. The brain's processing pathways face excessive friction from decoding linguistics and abstract theory at the exact same time. The consequences include a loss of sustained focus, sharp drops in comprehension, and total disengagement. This is particularly damaging in conceptually demanding fields like economics, where native-speaking instructors often maintain a rapid instructional pace. Struggles in these environments often stem from the structural limitations of text-heavy lectures, rather than a lack of student intellect. The question is whether modern artificial intelligence can alleviate this pressure. Specifically, can AI text-to-image generation provide the immediate, customized cognitive scaffolding required to support learners in real time? This document is a 2026 peer-reviewed study by Tricia Mengel, examining EMI Economics instruction in Asia. Historically, visual aids in language learning have often been treated as simple ways to maintain student interest. This study tests a systematic application of imagery. Strategic use of custom AI visuals provides the specific cognitive structure required for academic comprehension. The biological foundation for this approach relies on Alan Pavio's dual coding theory, developed in 1990. The theory states that the human brain processes information through two distinct cognitive channels, one for verbal and auditory input, and another for visual and spatial input. A standard text-heavy EMI lecture forces all complex data strictly through the verbal channel. When a non-native speaker is already struggling to parse the English language, this channel maxes out quickly, resulting in cognitive overload. By distributing this data across multiple memory systems, cognitive load theory suggests we can optimize the brain's resources. Engaging the visual channel relieves the pressure on the verbal channel. Utilizing both pathways simultaneously provides the biological support needed for processing abstract material when a student's linguistic centers are already operating at capacity. To test this, researchers implemented a specific intervention in a demanding environment, a first-year undergraduate EMI Economics course. The instructor utilized an AI text-to-image generation platform called Downshao to design visuals to accompany the lecture slides. To illustrate the concept of opportunity cost, the instructor generated a targeted image, a man distracted by work emails while sitting at a dinner date. The study enforced a design constraint. The visuals avoided unnecessary decorative elements and were embedded directly alongside concise text and key economic graphs. This alignment allows AI imagery to act as a cognitive translator. It converts economic theories into relatable everyday schemas, helping students grasp the material without adding extraneous cognitive load. To measure the efficacy of this approach, researchers administered a structured survey to 54 Asian students enrolled in a banking and finance program, assessing their cognitive and affective responses to the slides. The instrument proved reliable, yielding a Cronbach's alpha of 0.92. In Table 2, Item 1 shows a mean score of 4.46, indicating students agreed images helped them understand the topic easily. This extended to retention. Item 4 shows an identical 4.46 score, confirming visuals helped learners remember main ideas. Standard deviations across these responses are tight, ranging from 0.57 to 0.79. This indicates the intervention worked consistently across this specific cohort. Looking at the demographic breakdown in Table 3, males rated comprehension and retention items slightly higher than females. While aligning with historical research on spatial visual preferences, the p-value column confirms none of these gender differences were statistically significant. This cohort's feedback indicates that visual aids moved beyond general interest, directly supporting the comprehension of technical content. Beyond the numerical ratings, the thematic analysis of the students' open-ended feedback provides context about how these tools were actually used. Students reported relying on the AI-generated images outside the classroom. The visuals acted as scaffolding for self-study and textbook review, helping them better connect theory with practice. By providing a concrete anchor, the visuals allowed students to map complex, data-heavy relationships, like shifts in economic trends, that text alone failed to clearly convey. It is important to note the boundaries of this research. The study relies on a sample size of 54 participants and purposive sampling, which introduces a potential self-selection bias. Despite these constraints, the qualitative feedback shows students are actively relying on these visual scaffolds to navigate rigorous English medium coursework. Historically, the primary barrier to this approach was logistical. Designing customized, conceptually aligned visual aids required an investment of instructor time and specialized design skill. Modern AI text-to-image platforms remove the requirement for design expertise, allowing instructors to generate specific imagery for exact scenarios. This presents an opportunity for curriculum designers to integrate these visual tools beyond traditional language learning contexts and apply them directly into hard academic disciplines. As these tools become accessible, the reliance on text-heavy slides becomes a choice in instructional design, one that directly affects how non-native learners